Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, promise pool. It took a while for them to release this problem today. I don't know if somebody at Leetcode was sleeping, but this is a really good problem. It's pretty challenging, but it's also really fun in my opinion. We're given an array of asynchronous functions and a pool limit n, and we want to return an asynchronous function called promise pool. And even though it takes a list of asynchronous functions, it should respond with a single promise that resolves when all of the input functions have resolved. So at first, this kind of sounds like promise.all if you're familiar with that from JavaScript, but there's a subtle difference. Well, not super subtle. They explicitly tell us that there's a limit to the number of concurrent promises that can be active at any point in time, that can be pending at any point in time. So really, this is actually a lot closer to what a thread pool is, if you've heard of that. The similarities are that we do have some type of concurrency limit between thread pools and promise pools. Also, there is sort of a task queue. We're going to have like this list of functions. Let's say there's 10 functions, but our limit n is actually equal to 2, so we can only execute 2 promises at a time. And to understand this even better, let's just take a quick look at the example. It's a pretty good one. First of all, let's look on the inside because I think that's a little bit easier. We have a promise being created that will resolve after some period of time. Where does this time come from? Well, this promise is being returned from this anonymous method that is being assigned to this sleep variable. It takes a parameter time. So basically, this method, when it calls, will resolve after this many milliseconds. Straightforward. And we're passing in 2 methods into this promise pool. Of course, they're both asynchronous, but see, the pool limit here is 1. That means only one of these sleeps can be active at any point in time. I guess it doesn't matter what order we execute them in, because either way, we're gonna have to wait 400 milliseconds and then have to wait 500 milliseconds, or in the opposite order. The total is going to be 900 milliseconds when both of the promises will have resolved. So that's when this console log will execute. So it kind of sounds simple, but coding it up is actually kind of tricky. There's many common pitfalls, and I'll try to explain those to you. So first of all, this is an asynchronous function. So what should we be returning from here? And it's kind of obvious from the example. Promise pool returns a promise because we're calling the then callback on it. So here we absolutely should return a promise that we're going to construct. And we know that in promises, we pass in a method. Usually we pass in resolve and reject. I'll just tell you now, in this promise, we don't really need reject. They tell us that in the problem description. And we're going to call resolve only after all of the promises have resolved. So I'm just going to write that down here somewhere. We know we're going to have to move this maybe somewhere. We definitely don't want to call it immediately, but we know we have to call it at some point. So what should we start doing immediately? Well, we should probably start going through this array of functions. So I'm actually going to create a pointer I, which is going to let us do that because we know that we might not be able to go through all of them immediately, but initially we can probably do at least n of them like this. And then on each function, we want to probably initiate it. We'll call it. So at the I index, this is a function, and then we want to call it. I don't think we actually have to pass in any parameters. It doesn't look like we were given any arguments. So let's keep it simple for now. But this is pretty simple. This will start like n promises, but it could be possible that we have a bunch more that we need to do. So how do we kind of do that? Well, normally when one of these promises completes, we want to start another one. How can we do that logically? Well, the simplest way is typically with then. And what do we want to do when one of these completes? Well, we want to execute some piece of code, which probably just using the I pointer because it is accessible from here. We can just maybe do the exact same thing we did here. So it's almost recursive in nature, right? We're calling another function like this. Now, one important thing, we probably shouldn't forget to increment our I pointer. We can do that down here like I++, but we can also do it over here because this will be incremented after we execute this. So when one of these completes, we start another one, but how do we know we've reached the limit? Like in here, maybe we get to the point where I is equal to functions.length. We've reached the end of the functions array. We don't want an out of bounds error down here. So this is sort of our base case, and this is probably where we want to call our resolve method. So we can get rid of it down here. But believe it or not, this has a bug as well. Just because our I pointer reaches out of bounds, that means we have no more promises or functions left to call. But that doesn't mean all of the pending promises have completed. So how do we even keep track of that? It's not super straightforward, but in our case, we kind of do need a separate variable for that. So I'm going to create in progress. Initially, it's going to be 0 as well. And every time we start one of these promises, we then want to say in progress plus plus. And when one of these completes, which we know from the callback here, then we can in here say progress minus minus. So now to update our base case, we want to execute the base case when this is true, but also when in progress is equal to 0. We have 3 equals because JavaScript is dumb. There, I said it, okay? And resolve sort of acts like a return. So this is kind of like our return. Like if this executes, we probably don't need to worry about this, but you can see that this is kind of messy. So I'm actually going to go ahead and move this into a separate function that I'm going to define down here, which I'm just going to call callback, I guess, and then copy and paste it and get rid of this. So that's no longer an anonymous function, but it is definitely more readable. So now we're going to use this callback down over here. Now, believe it or not, there is another bug here, and that is what happens if functions array is empty? Well, this loop isn't going to execute, or actually it is going to execute, assuming that n is positive, and we're going to get an out of bounds error here. So here, before we execute the loop, let's also check that I is less than functions.length. And now back to my earlier point, if functions is empty, yes, now this loop will not execute, which is good. We don't get an out of bounds error here, but this won't execute. I mean, this is just a function definition. So nothing in here is really going to execute if the functions passed in are empty, which means resolve is also never going to execute. So this is going to be pending forever. So what we can do up here is add a base case, sort of, which is that if I is equal to functions.length, or you could just say not functions probably, we can just call resolve up here. And there are still bugs here. When we normally execute a function, we do want to increment the pointer for the next time. And we see we are doing that up here, but we're not doing it down here. So what we could do is increment the pointer down here. But at this point, you kind of see that we have some duplicate code here. We're calling a function here, and we're also calling a function here. And every time we call a function, we want, when it's completed, to then execute the callback. So actually, we're missing this piece of code here too, which at this point should kind of encourage you to clean up this code to make it more reusable and less error prone. And I see that we're also missing this plus plus, so let me add that as well. That'll help us kind of refactor the similarities and differences. And another bug, believe it or not, is here. If we have reached out of bounds of the functions, which means we have no more left to call, but we still have some in progress. So resolve is not going to execute, but the rest of this is going to execute, which means our I pointer is going to be out of bounds. So that's a problem. So I'm going to rewrite this to just check if I is less than functions.length, then we want to execute this function and increment I at the same time, but else if in progress is equal to 0 and I is implicitly equal to the length because that's else from this condition and getting rid of this part, then in this case, we can go ahead and resolve. We have no more pending in progress function. So this is definitely tricky, and we can probably move this up to the function call as well. So at this point, I'm thinking of just moving all of this code inside of the single callback method because this problem is pretty much recursive in nature. You can see the function is being called from within itself. So I'm just going to cut all of this and then move it down here. And the variables are defined outside because we want them to be persistent. Every function call should be able to share these variables. That's why we're defining them up there. Now to combine these two pieces of code, We can either execute a function with a loop or we can execute it with an if statement. I prefer the loop because that, of course, will let us execute the first n functions. And then on subsequent times that this callback is called, we'll find maybe that one of the promises just completed. Therefore, the in progress value was decremented. And then we should be able to do another function call. But how do we keep track of that? Because this is going to try to execute n calls every single time. Well, that's kind of why we have our in progress value in the first place. In progress is the one that should always be less than n. There's going to be cases probably where I exceeds n. So that's why I is bounded by the length of the function. And in progress, where should this be called? Should we just move that to the beginning of the callback? But ultimately, we want to call this callback. Yes, it's a recursive function, but we want to make sure we call it. And I don't think the return value is actually needed here because we are inside of a promise. But back to this in progress, when do we want to decrement it? Well, only when a promise completes. So we should probably just move this inside of this callback over here and defining it differently like this, an anonymous function, which is now actually going to do two things. It's going to decrement the in progress and it's going to call the callback recursively after every promise completes. So now we're starting to get pretty close to the solution here. We don't really need this piece of code because the loop will make sure that like the callback is executed until this condition has no longer been met. So let's get rid of this part. And lastly, this is sort of like our base case, isn't it? If in progress is equal to 0, well, that's not enough, clearly, right? We need I equal to functions dot length, and this is the case. Then we resolve. And you can see we kind of have a duplicate up there. So we probably don't need that anymore. So I'm just going to take this bottom part and move it up there. And we have finally gotten pretty close to the solution we wanted. You can see there's not a ton of code left. We are handling the base case. We're immediately executing n functions if we can. And then we always restart one as soon as one completes. So let's go ahead and run this to make sure that it works. And as you can see, yes, it does, and it's pretty efficient. Now for the second solution, let's go back to the idea of promise all. But the problem is, remember, we can't necessarily execute all of these promises at the same time. That's what promise all does, simultaneously executes all of them, but we can only execute up to n of them. So instead of passing them in line, first let's actually get a subset of those functions. So what we could do is take the first n functions and then pass them into promise.all and then await this promise. So in this case, we're going to be using the async await pattern. But even if we do that, we don't want to just execute the first n promises. After each of these is complete, we want to execute the next one in the list. How do we keep track of that? Well, again, we can just use a pointer. In this case, I'm going to use I, but I'm also here going to define a function, which is going to be the callback, which after one of the functions completes, we want to execute this piece of code. So after a function completes, what do we want to do? We want to then get functions at index I, call it, and in this case, let's await it. And if we're going to do that, we probably also have to make this async. And also let's remember to increment that I pointer. Now, after one of these is complete, what do we want to do? We probably just want to call the callback again, remember? And before we were doing it with the then pattern, but in this case, we're using async await. We're awaiting this line so that we know for sure that that is complete before we then execute the next callback, which will then execute another function. But this looks like it's going to go on forever. We forgot to add our base case. Notice this is a recursive function. The base case in this case is going to be functions dot length, or rather I is going to be equal to functions dot length. And if that's the case, then we simply return. There's no need to resolve here because we're not actually creating a promise here. This function is returning a promise, which in this case looks like it's just going to return undefined anyway. Okay, so how can this be used with promise all? Well, it's actually simpler than you might think. Why not just pass n instances of this function into promise.all? Each of them will execute in parallel, And then when each of them is complete, it looks like it's doing exactly what we want. It will then start another one of them so that at any point in time, only n of them will be executing because we're going to pass in n promises. And to do that, let's actually go ahead and build those promises. So I'm going to say const n promises is going to be equal to, we could create an empty array and just say while I is less than n, we're going to go ahead and say n promises push. So then when we push to this array of promises, we don't push one of the functions, remember, because when one of these promises completes, we then want another one to be triggered. So we have to add some extra behavior. So we kind of added this callback wrapper function around this function so that when this is done, then we execute another function. So then you might think, let's just pass in the callback. Well, remember, the callback is the actual function itself, but we want this to be an array of promises. So we actually have to call the callback. So this will create a promise. Maybe it evaluates immediately, or maybe it's still pending, but then we take this array of promises and then pass it to promise.all, which will then wait for all of those promises to complete. So the last question you might have is, why does this await not just wait for n promises? Why does this necessarily wait for every single function to be called? And that is because if I have promise 1 and promise 2, and these are the only two promises I pass into this guy, but it actually turned out we had 3 function calls. What's actually going to happen is promise 1 is not going to complete, believe it or not, until the other promise that it triggers also complete. So this is going to create another promise, and you know that because this is the recursion. We're waiting for the function call to be completed, but this wrapper promise, this is a promise around another promise, and it's going to keep going like that because that's what recursion is. This might keep calling other promises, and then when like this promise completes, we pop back up here. When this promise completes, we pop back up. And then when the root promise completes and the other root promise completes, that's when promise.all says, okay, we're done. And then we can stop. And that's when this promise will no longer be pending. And actually, I just noticed one last bug here, which is that we're taking this I pointer, but we're never actually incrementing it. And we actually don't want I to be incremented in this case because we're incrementing it already inside of the function and we don't want to corrupt that value. So let's actually take this and rewrite it a pretty JavaScript way. Now that you kind of know exactly what the solution is, we have here an empty array, but if we want to initialize an array of n values, we can do that like this. Well, I guess it doesn't actually have n values, but we've allocated the memory for it, and then we can fill it with a bunch of undefined values, or you can just pass in like 1. You could pass in anything you want here, really. I'll pass in 1. And then for each 1 value, we can map it to something else. But actually, in this case, I'm thinking maybe we can't fill it with 1 because this function is going to be passed in undefined. There's no parameter here. But normally what map does is it takes in some function, usually an inline function, and it takes every value from the array and maps it to something else. In our case, we want the result of this callback. We actually want that to be called. So we're just going to pass in this function. We don't have to call it. We just pass in the function and map will call that for us. So this is pretty much doing what the previous code was, but we're not corrupting our I index. So now let's run this code to make sure that it works. And as you can see, yes, it does. But if you found this helpful, please like and subscribe. If you're preparing for coding interviews, check out Leetcode.io. It has a ton of free resources to help you prepare. Thanks for watching, and I'll see you soon.